First of all, thank you to Ryan for the cookies.
Thank you,
Second of all, you have to solve this problem during the course of the class period.
Oh, during the course of the class period?
Yes, during the course. I have nothing to say about that. Well, then you don't get the benefit of solving it.
Wait, I gotta solve it already.
I am also.
If you figure it out, don't tell anybody. You could work with a buddy, but
That's just the same thing.
don't tell people who don't. I don't know.
Let me just tell you how it is.
All right, so you can be contemplating that problem while the class period is going on. We've got a demo day going on, and we've got a related rate problem that we need to solve. And I think I've got a setup here that's going to work. I've never done this particular one before, so we'll see how that goes. All right, go find your packet on related rates. This is our final day of related rates. And open up to the last page, which is the conveyor belt problems. Okay, we're on the last page of the packet. Find the conveyor belt problems. Nobody said it was supposed to be funny.
I thought it was
I thought it was going to be a real answer.
All right, we're on the last page, the last two problems, the last page of the conveyor belt.
I get it.
Now I get it.
Are you kidding me?
Figure it out. Okay. All right, let's get going. So, sand on a conveyor belt problem. This is kind of a classic related rate one. As you can imagine here, we have at a sand and gravel plant, sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. Okay, this is the problem that we're dealing with. And then it says the diameter of the base of the cone is approximately 3 times the altitude. And then we got a couple questions that we have to answer. So we're going to set this one up first. And then we're going to do the demo. And we're going to see where we go with this. Okay, so let's set it up. So on your paper, whenever you do a related rate problem, or for that matter, any kind of problem, identify what you know and what you want to know, and then any other things that will help you to get there. It's actually a really good problem-solving technique. And I've got myself a picture here, plus there's other things that we're going to have to figure out. So, what can you bring me for this? What can you tell me? Any part of this that you know? Yes. A altitude equals 3d. That would be here. If you don't mind, I'm going to use h for altitude. Opposite. What do you mean by that? The diameter is 3 times the altitude. So I'm going to use h for altitude.
That could be the equation.
Well, that relates d and h. Okay. We'll find out if there's anything more that comes from it. That's an equation. It says that the diameter is 3 times the height. Okay. When it forms, it should form this pile that it's like bigger and bigger and bigger versions of itself that are similar. That's what we're going to try to see if that actually works over here. Okay, what else you got? Extract the information from the problem. Yes?
It falls at 10 cubic feet per minute.
Okay, so we know 10 cubic feet per minute here. Okay, what is that? What should I assign that number? It's dV/dt. Okay, so let me explain that. When the sand pours onto the pile, the sand makes up the volume. Okay, as opposed to like filling a tank with water or something like we were doing yesterday. Here, the sand makes up the volume. So if the sand is falling onto this pile at a rate of 10 cubic feet per minute, that's what the volume is being added to the cone. That's why it's dV/dt. Okay, what else we got? Or what do we want to know? What's that? A and B. So, what does that mean? Yeah, what do we want to know in part A? dH/dt. Do we want to know the rate that the height is changing in part A? Okay, so that's what we want to know here. And in part B, what do we want to know? dr/dt, the rate that the radius is changing. These are the two things that we're going to solve for. Okay, do we have an equation that relates everything? Volume of a cone. Volume of a cone is 1/3 pi r squared h. Now, on the AP exam, they'll give you the weird ones like that. Okay, so if you have to do that, that's what we do. Okay. So let's do the demo now, then we'll come back and we'll finish this thing. So I have no idea if this is going to work or not. So I'm going to pour the sand in. Now the rate that I pour it in really doesn't matter. I'm only looking to see if the shape of the cone stays. You got to see if it looks like it follows like a similar path. So I'm going to try this. I don't know if this is going to work. This has got a good chance here. Okay. So if I pour the sand in, it's going to fall, and will hopefully the same size that it starts off at, it should end at. Give or take a little bit. So. Okay, gotta make sure I don't get it right here. Amy, hold that, hold that.
Go ahead.
Straighten it out.
Oh, you messed it up, huh? Can you go
I did not do anything.
Okay, okay.
Not my fault.
That was nuts.
What happened?
It wasn't going down straight.
I was thinking about having one of those pools, those kiddie pools.
Yeah.
Now you know what might be impacting it is how far I am away. If you're close up, can you see it kind of like destroying the pyramid?
Can you pour the whole thing in?
Yeah.
Well,
big enough.
yeah, I'm gonna pour the whole thing
I won't.
in. I'm looking at it from the top down and it looks like I'm making a pancake.
Plants are good. It looks like an anthem.
Now what happens here is, you see, it's like nature has this cool way of figuring out how to distribute things in a way that forms the shapes that we do in geometry. You see, the reason why we figure out the volume of a cone in geometry is because a cone is a natural thing. Okay? We don't really try to find the shapes of things that no one ever knows anything about. It's really cool if you look at it from the top. It knows where to go and everything slides down just the way it's supposed to. If it gets too big on one side, and then it starts doing the other side.
All that work.
We'll start
You can't let the sand on.
Gotta
Yeah.
start again.
I'll just
Amy, are you gonna
press-
put all the
I'll
sand
just
back
press
in?
undo.
We don't need to learn anything today.
Aren't you learning something right now?
Amy, you know a mole lives underground, right? Yes. So it's like a new look of well, I do live underground. Moles live underground. They don't necessarily live in holes, but I'm assuming there's some sort of zone made by them burrowing upward. Oh, because it was on the bird show. Where it's how many times do I need to bring things out?
Amy, you should definitely get all of your information from Phineas and Ferb.
You like
Hey, I learned what I did from SpongeBob.
I never watched SpongeBob because I heard from one day. if I stopped walking altogether. Sweet like exactly. Yeah. Yes. The twins.
Kirsten Hutch, you also was hot. They're all unquestioned. Do you like how they're distracted? Internet! I could have used the internet. I took it home last night. He never told me that. No, I was being a good student and you didn't say that. That's okay. That's angry, frustrating. Frustrating?
Amy, no.
That makes me angry. Because there was 4 questions on the benefit we never went over.
I'm getting really distracted.
Kevin, that doesn't count for the circular shape.
That's what they have. Yeah.
Did you say the congressional
And they
library?
just put more,
Did you say
they
the
put wooden posts on the edge of them.
proposed spending
No, because then I want to go to Egypt. No, well, I think there was something like like we tried Egypt. We tried shutting the person down too. Remember that? No, we can't put that person in.
Well, that makes me
No, it's so fun to watch because it all like collapses.
What like natural sense would like sand be falling at this angle like that?
How would that work out?
I would say, maybe just think of a glacier when there's a hole and it's melting and all that stuff will fall in, something like that.
Mr. Johnson, I think we should take a class for thinking of the roads.
Yeah,
Have you ever been there?
yeah.
That's fun.
I think all of us would fit in it, just barely, not that big.
I have a question. You guys there?
I think we should go.
They come off the conveyor belt though. Is it just like dropping off like completely? Wouldn't it like not come out on one strand, so it come out in like a pile?
No, I think it would come across, it would fall similar to this. Because it just, it's falling at this rate. It would be similar to this, but not exactly the same. All right, write these numbers down. We're going to see if our cone is a 3-to-1 ratio. Okay, I don't know if it is. So, diameter is 48 centimeters. Oh. And this is 16. The height is 16. Okay? So the problem that we have there is, this is what it looks like. 16 and 48. Isn't that cool? I did not know if that was going to turn out that way. Okay. All right, so. Yeah, that's why I'm gonna drag this whole thing out, and then I'm gonna scoop it back in there.
You could just put right at the
Make a conveyor belt.
Let's try cleaning it up right now so no one falls over it.
Yeah, that'll be a good way to burn 25 minutes.
Yeah.
I know what you're thinking. I've seen you on video. Okay, here we go. So let's solve the problem. Volume is equal to 1/3 pi r squared h. Okay. So there's actually going to be, well, I'll show you the natural way that we would approach it and we're going to watch what happens. So obviously over here we have dv dt. We're out to find dh dt in the first one. So let's just go ahead and do it. So we're going to find the derivative of this, okay, with respect to t. So dv dt equals 1/3 pi, you know, that's a constant, 1/3 pi. And so I'm going to treat this then as the product, and we can just multiply the constant by the product when we're all done. So derivative of r squared h, we have to use the product rule. So we'll let r squared be the derivative first. So dr, 2 times r dr dt times h plus r squared times the derivative of h with respect to t. So that's dh dt. Okay. Now that's a whole lot of variables. Okay. Let's see, 1, 2, 3, 4, 5, 6. 6 variables in that problem. And that means we have to know 5 of them so we can figure out the 6th. We have to figure out what dh dt is. So I could solve this for dh dt first if I wanted to. In fact, that might not be a bad idea. Let's do that. We're going to solve this for dh dt. So dv dt is equal to 2/3 pi r. Now watch this. 2/3, I'm going to distribute 2/3 pi r h dr dt. Now I just changed the order a little bit there. But make sure I got everything. 2/3 pi r h dr dt. And then this is 1/3 pi r squared dh dt. And then to solve for dh dt, see, let's do this all in one step. I'm going to subtract this whole term, and then I'm going to divide by this whole term. So it's dh dt equals dv dt minus 2/3 pi r h dr dt divided by 1/3 pi r squared. Everybody agree? Did I do that right? Okay, now the fun part, we're going to just plug everything in. So dh dt equals dv dt is 10 cubic feet per minute minus 2/3 pi r. R. Is there any specific moment where we're stopping this and we're trying to figure it out? What's 15? The height? Okay, so I'm going to replace this, or I'm just going to say this is 15 feet. Okay.
I'm sorry.
So we're looking at h equals 15 feet. And so does that help us? I need radius, though. If the height's 15, how much is the radius? 22.5 is correct. Okay. I'm going to make a little comment here. D is equal to 3h, but diameter is 2r. Right? So that means the radius is equal to 3h over 2. 3 times 15 is 45, divided by 2 is 22.5. So the radius is 22.5 feet. Okay, so that one we got down. 22.5 feet. Okay. What's next? H. What's H? 15 feet. And dr dt. What's dr dt? Uh-oh. Uh-oh. This equation relates R and H, correct? So equations were born to be manipulated. So we can take the derivative of both sides of those. So that means that dr dt is actually equal to 3 over 2 times dh dt. That is, the rate that the radius is changing by is equal to 1.5 times the rate that the height is changing by. So what does that mean? It means I got to change this. Normally I would put dr dt in there, but since I don't have a value for that, I have to replace it with 3/2 dh dt. And we might have to redo where we went with this. Let's just see if we got everything else. And I'll show you we might have to do another run at this. Pi radius is 15, we said. No, 22.5 feet squared. Now, do you see the problem here? This is the variable that we went out to solve for, but it turns out that the variable also is in this side of the equation. Okay? So that means it's like this is an x and then this is an x, and we have to still solve for x. Okay? If I were do the problem, I'd scratch the whole thing and let's start over.
I really hope everyone was right.
Now, what we could do is we could multiply this times the bottom, and then we could bring this term over here, and then solve for dh dt. It would work out algebraically. What do you want to do?
That runs the back in the left.
Just finish this one off?
Yeah.
Okay. Are we okay with that? I'll show you the other way too. We'll show you how it can be done either way. All right, so we're going to cross multiply and solve. Okay. So I got 1/3 pi times 22.5 feet squared. Hello, sir. Come on in. No, we got a cookie for you. Plus a puzzle. Plus a candy bar.
Yeah, it's fine.
What? No. Okay. Okay.
Do you know what the inside joke is?
No.
Mr. Jen's like, okay. Oh my goodness, Corey, look at him. Oh, God.
Okay. Feet cubed. Okay. So took the bottom here, multiplied by dh dt, and then the top stays the same. Okay. Now I'm just going to bring this term. Now see, there's only 3 terms here. It's just this guy, and this guy. Okay. In all honesty, it's like in algebra if you did something like this. 3x is equal to 4 minus 2x. That's all it is. Where the dh dt is the x. It's similar to this solving this kind of problem. So I'm going to add this term over to the other side, and then we can solve for dh dt. So here we go. 1/3 pi times 22. I'm going to drop the units just for right now. So 25.4 squared dh dt plus 2/3 pi 22.5 times 15 times 3/2 dH dt is equal to 10.
Would something like this be
I've seen a problem in a free response like this. So we're solving for dH dt. So all we're going to do is factor out the dH dt and then divide by the answer. It's no big deal. So I'm going to pull out the dH dt here. And notice this is all that's left over. 1/3 pi times 22.5 squared plus 2/3 pi times 22.5 times 15 times 3/2. Hey, those cancel. Is equal to 10. So now you have to just take 10 divided by that thing. Come on. And we solve. 10 divided by that equals. I'm going to look for an answer from you. And then we're going to solve it in alternate way. The other way I think goes a little bit faster. We got to see if we get the same answer both times, so yeah, I need an answer. .02, we have an answer. I don't remember what the answer is.
Yeah, 0.0164. What you got? Third person? Anybody first? What'd you get? 0.0164. So did I. They made me say
0 what? 0 what?
0.06287.
Okay, that would be good enough right there. 4 decimal places. No, you don't round. 4 decimal places, just drop it off. Just leave it.
No, we said no. Why not?
You write 4 because the AP calculus test looks at the first 3, either rounded or truncated. So if we write 4 without rounding, we'll always get it right. All right, this is feet per minute. Okay, let's see if we get the same answer. I'm going to do it a different way. This one might turn out to be a little bit quicker, but you got to spot it. You got to spot it early to make it work. Okay, here we go. Same exact problem. Volume is equal to 1/3 pi r squared h. Okay. But this time I'm going to recognize that, remember this d was equal to 3h? And then we converted this into radius versus diameter. And so the radius was equal to 3/2 h. Okay. If you spot this early enough, you can do that substitution right away. So since I want dH dt, I'm going to substitute this 1/3 pi, and instead of radius, I'm going to put in 3/2 h squared H. I want dH/dt, right? So if I have an H in the problem, and then I have a V in the problem, I got a problem solved, because I have everything that I need to. So I'm actually rewriting the original equation, but because there's a ratio between R and H, I can substitute. So watch this. This becomes, I'm just going to clean this up a little bit. This is 9/4 times H squared times H. Do a little canceling. Volume is actually equal to 3/4 pi times H cubed. Same formula, but just using different numbers. This formula, with a ratio of R is equal to 3/2 H, is actually the same as 3/4 pi H cubed. See it? Now watch. When I find the derivative of this, dV dt is equal to 9/4 pi R squared, pardon me, pi H squared dH dt. And if I solve for dH dt, it's going to be dV dt divided by 9/4 pi H squared. A little bit quicker. Yes? 9/4. Bring the 3. Yeah, it's 3/1. So it's 3/1 times 3/4. So, dH dt, therefore, dH dt is equal to, we can plug everything in. This is dV dt on the top. So that was our 10 divided by 9/4 times pi. What was H in this problem? The 15. Okay, so help me out. What's 10 divided by 9/4 pi times 15? Squared. The same number. Okay, does that make sense? Now, we would have had to spot this way early in order to do this. Okay, but it works. That one still worked in the end. It was just a lot of extra manipulation. But this is also how you can do the problem. Okay? Any questions? All right, we're not going to do the second one. You can do that one on your own. You have officially really no homework for the whole break. So when you come back, I totally and completely anticipate you being fired up and ready to go when you come back.
For the test.
For the test chapter.
Will this